HTML as well. So when you go there, when you go into the comments, you will see a link, and you can actually have those exact same slides in your browser. So before we get started, we'll just take a quick look back. We'll do a quick recap of the versions that have taken us here. We'll take a look at the timeline, see when the different versions came around. We have the version 3.0 of the framework, which came in December of 2009. And that was a major iteration, a major version of the framework. We had a rounded support for REST, comprehensive REST support, which started in 2.5 but really got a lot of features in Spring 3. We evolved the @MVC, the annotation-based programming model for Spring MVC. We got a new type conversion system and lots of other cool things. The MVC namespace also came in version 3. Then 2 years later, we have Spring 3.1. Seems like a long period for a minor version. It is a point release indeed. The main point here is that there's nothing that's too significantly new or radically new. There's no kind of a revolution in the programming model like we had in version 3 with the comprehensive updates to REST. But at the same time, we have basically just the evolution of the existing Spring 3 programming model, but there are tons of new features. So that doesn't mean that there aren't any new features. It just means that they're a natural evolution, a natural progression of what we already know as the programming model, just putting refinements, adding new features, and making more things possible. So just a quick recap of some of the things that we had in 3.1. We had the addition of MVC Java config in addition to the MVC namespace. The ability to initialize, this is in Servlet 3 containers, the ability to initialize without WebXML using Java. Spring Web makes that a lot easier. We have completely revised infrastructure classes for the annotation-based programming model, which from a programming standpoint doesn't really make a huge difference. But it makes a big difference to us, and it makes a big difference to a lot of you because you do work and you do look at some of the underlying classes for extension points. We had major revisions to the content negotiation algorithm. We had the addition of the ability to map by content type, whether it's for the incoming request or for the response. And we also added redirect and flash attributes, made URI variables available in lots of different places, like for data binding purposes. I think maybe still a lot of people aren't quite aware of this, but just like you have request parameters and you can map onto an object, you can also do the same thing from path variables or URI variables. You can include them in redirect URL, so if you're redirecting from your controller, you have a string and you can put URI variables in that. Also during rendering, those path variables become automatically available. We have a nice addition called URI Components Builder as well, which allows you to build URLs and it allows you to encode them. And if you're familiar with the URI template, which is used by the REST template, it's sort of similar idea but more builder style and gives you really full control over the steps you take to prepare a URI, to expand some variables, to encode them, and so on. So it's really nice, actually, has lots of good parts. And if any of you are familiar with the Spring Hate AOS project, not really sure what's the best way to pronounce that, but it's basically hypermedia links, being able to return responses which have links to other resources. That's a new project, relatively new, and that's creating links directly off of the controllers by reusing the request mappings. So it's very useful. That's using the URI Components Builder as well. And you can have a URI Components Builder injected into your method, and then you can start building links relative to the current request. So it's kind of useful there as well. We have support for Servlet 3 multi-part requests, sort of as an alternative to the Apache Commons. library which has been around for a long time, and we have a request part annotation which allows you to, if you're sending multi-part content with part JSON, part file upload, which is something you can do with REST services, then this is something that you can use to extract a specific part and have it converted, just like with request body, but this is for multi-part requests. So this was all part of Spring 3.1. There's other features which are not listed here. A year ago, and here we are with Spring 3.2. This time, 1 year later, we're expecting that to be in December. A RC1 version is going to be available shortly after Spring 1, probably about a week after, and then we're looking at a final release at the end of the year. So some of the new features at a glance, we have asynchronous support for asynchronous requests based on the Servlet 3 API. We have some additions around reporting errors in REST-based scenarios, which we'll talk about. We have the notion of content negotiation strategies. It's a new abstraction which helps to configure how you want to deal with content negotiation, especially considering that accept header is not always the most practical approach when you deal with browsers which send different kinds of accept headers. Sometimes using an extension on the URL is actually the first thing you want to try to match on. And then we have support for matrix variables. I don't know if anybody's ever used that, but you can find them now in the wild. I'll show a couple of examples of real-world APIs that are using them. And Spring MVC test framework, this is something which has been in the works for at least a year. And it's a very exciting addition, which I will demo a little bit, but actually I have another presentation on Thursday morning that you can come to, and we're going to cover in a lot more detail not only that, but other additions in the Spring test module related to web applications. We have a pretty good story there for Spring 3.2. And there's other smaller things as usual to cover as well. Now, starting with async support, we're all familiar with HTTP request and response semantics. So that's our starting point, really. Client, always a client initiates a request, and then the server is going to handle that request, do some processing, and then return a response. So we have this back and forth, which is always sort of unidirectional. It goes from the client to the server, and then the server responds back with the data. And AJAX requests came around some time ago, and they allowed us to reload a portion of a page without actually reloading the entire page, giving you the sort of the feel of asynchronicity on the page, something happening dynamically without reloading the entire page. So they appear to be more dynamic and more live. But at the same time, what's going on under the covers is still the same request and response semantics. Nothing has changed. You're just doing that using an AJAX request. And when we try to introduce a live sort of aspect, live nature to an application, there are sort of different degrees of liveness that we may desire. So, for example, in some cases, it's okay to poll every few minutes. It's perfectly acceptable. If you think about a mail program, checking for mail messages, or Twitter, or any kind of social stream, even breaking news, if you don't find out exactly, within 10 seconds, if you find out within 2 minutes or 3 minutes, that's perfectly acceptable to send a request every now and then and just see if there's anything new. In other cases, it's just not real-time enough. So if you talk about, for example, chat, if you're chatting with a representative on a website, trying to get information, obviously that 2-minute delay is going to make a huge difference. You want that to be as close to real time as possible. Same thing for any kind of collaboration application or other applications where there's a large amount of information flowing back and forth between the client and the server. So if you talk about trading, finance, these are the kinds of applications that often tend to have a larger volume of data going back and forth. And in those cases, it becomes less efficient actually to make additional requests. And remaining within the realm of the HTTP request and response semantics, And we're not going to talk about WebSockets yet. We do have a talk on that tomorrow morning. I have a talk with Chris Beams and Gunnar Hiller. So remaining within the semantics of HTTP request and response, what we know and what we're familiar with and what is supported in the Servlet 3 API, the technique of long polling essentially can be described in a simple way as follows. A client sends a request as always and then waits for a response. The server is actually not going to respond right away. The server is going to hold on to that request until new data arrives. Because the server doesn't have any opportunity to push data to the client, effectively this is the best way to simulate close to real time without polling constantly trying to find out. I've seen this described as if you think of a young child, being impatient and asking for, when are we going to open the presents, constantly. Versus a cool teenager that lifts off his headphones and says, let me know when we're going to open the presents, and just goes back to listening. So it's a bit like that. So if your messages are not flowing all the time, if there is some sort of lag between the messages, then definitely long polling is going to be more effective and more efficient. So the client will just resume sending requests and waiting. Server will hold until new data arrives and just keep repeating that. So it's very similar to what we already do. It's request response. We have a kind of polling, except the server here takes extra responsibility not to respond right away, but to somehow manage to hold on to that connection without using up all the threads, which we're going to get to in a second, and then responding when some new data arrives. And there's lots of scenarios that you can think about here. I mean, probably the simplest thing to consider is just long-running requests. If you're hitting a database and it's going to take a while to respond. If you're going out to a third-party API, but then there's also other things like you might be waiting for events to arrive, like a JMS message or something that you want to relay as soon as possible, as soon as it arrives. So the effects of long polling are basically that simulates a kind of server-side push with HTTP request and response semantics. And in many cases that's more effective than polling. Because if you want to get close to real time, with polling, your best chance is to just keep polling all the time as quickly as possible. Whereas with long polling, when there is no data coming immediately, you have this wait that reduces the need for you to go back to the server constantly. However, it does mean that requests are going to remain open for a much longer period of time. And when you have that, and when you know how the servlet containers work, obviously that presents a challenge that needs to be looked at. So with servlet containers, what we have is the traditional thread per request processing model that we're all familiar with. But of course, with long polling, if we take this strategy of one thread is going to now sit and wait until we have some new data, we're very quickly going to exhaust that thread pool. So that's not sustainable really, and that really sets up the motivation for asynchronous processing and the features in the Servlet 3 spec. So if you think about the servlet thread model, essentially what we have is a servlet thread gets dedicated to the incoming request, and we start to do some processing as usual. We get to the controller is going to do some work, and then we're going to prepare a response and send it back, and that's how every incoming request works. With the Servlet 3 async thread model, the way things change. So we still have that incoming servlet thread, which is going to be allocated to the incoming request. It's going to start to do some processing. And then at some point, we're going to decide that this is a request that we want to process asynchronously. In other words, we want to sort of release the servlet thread, and we want to do some processing either in a separate thread immediately, or just wait until something happens and then be ready to send back. So we are going to switch to an async mode, and I'm not covering specifically the API mechanics of doing that. I think there's a lot of information on that out there, and it's less interesting than sort of getting the concept here. That we're going to switch to async mode. We're going to indicate, it's done through the HTTP servlet request. You're going to say start async, and that indicates you're switching to asynchronous mode. And essentially what happens from there is you leave processing. You just leave the controller method, then the dispatcher servlet leaves, all the filters are exited, and the thread that belongs to the servlet container is fully released. It goes all the way back to the container. However, the response remains open, so we can still complete the response at some time later on. So what's going to happen is that we're going to either start an application thread to do additional processing, or we're going to rely on some external thread. For example, if you have a JMS listener that might be receiving events, so there's a thread in which you might decide to complete the response. If you have AMQP, something along those lines, once again, you have some sort of a listener there that can produce a result. And once we have that result, we want to dispatch back to the container in order to resume processing and to finish processing with that result. So if you look at the first thread, basically that left in the middle of things as quickly as possible. Then the second one produced the result, and now the last thread is the one that's going to actually finish what we left in the original thread. So when we dispatch back, you can think of a dispatch as something being similar to a forward. I think everyone is familiar with forwarding in servlets. So dispatching is kind of similar, but you're doing that from an asynchronous thread and not from the main thread. So why don't we just finish things off in the application thread? That might be a natural question. Why do we need to dispatch back into the container? Seems like this back and forth. It's actually something that we tried in milestone 1. That was the original approach to our support. But it turned out that the HTTP servlet request is really not so usable outside of the servlet container thread. And kind of a simple way to explain why that is if you think about forwarding one or more times, say one controller forwards to another and so on. Then you start asynchronous processing. Now you're holding on to a request, but meanwhile the original thread is exiting, and it's exiting the forwarding from one controller to the other. So the actual data in the request is changing. What is my current path? When I forward, my path changes. So there's things in the request that change. So effectively the request is not something that you want to use from an asynchronous thread. And that's what we found out the hard way, because the spec really wasn't very explicit about that. There wasn't anything that said that the HTTP servlet request really shouldn't be used outside of a servlet thread. So we found that out through an issue reported, and then we went back, revised the whole approach. So there are these kinds of limitations which should really be done inside a servlet container thread. Also, something should be said about the response really should be finalized ideally within the container. That's kind of the ideal situation. Because if you think about things like errors being raised when they bubble up all the way to the container, then container has a way to handle them. And for consistency, what we're aiming for with our support is trying to get to a point where when you're doing an asynchronous request, everything you know about the Spring MVC lifecycle doesn't change too much, doesn't change radically and fundamentally, so that you can still continue to reason about what's going on. So we're really going as far as we can to try to maintain that programming model. So what does it look like in Spring MVC? So let's talk about that. Question, yes?
How would this work with Spring remoting? For example, if your application service layer is in a different container, and at some point in time you want to distribute them for whatever reason.
Okay, so the question is, how does this relate to Spring remoting, essentially? Well, Spring remoting gives you different options as far as what kind of remote procedure invocations you want to make, and one of them is HTTP-based indeed, but it's just following regular HTTP-based semantics. The async support that we'll see here is built on top of the annotation-based programming model for controllers. So that's really where it's provided. But the actual underlying support is on a more fundamental level, which is usable even in places like Spring remoting. But that said, we haven't really built anything specific around Spring remoting, so there isn't anything to say there. which is not to say that we can't put it. We just probably would need to think about use cases. I just don't see anything immediately there.
To me, it's like a callback pattern, right? Except the callback is remotable.
Yes.
To a large extent. And in multi-tier architectures, you may have different tiers that are going to execute certain logic, and it may not return on time.
Yeah.
You want to have similar semantics even there.
Even there, of course. Yeah, that's a good idea. And actually, I presume you're referring to the Spring remoting, which works on HTTP, on top of HTTP, right? So feel free to actually file an issue if that's something that you can describe and use case that you have. That definitely sounds like something that we can look at. And once we have the fundamental support, it shouldn't be really, now that we have it, it shouldn't be too difficult to make that possible as well. So we'll consider it. Okay, so the two options that you see here, well, there's actually several new return values, but with the annotated request mapping methods, we have inputs and outputs, and typically things that have to do with the response are something that we return as return values from these. That's kind of the programming model that we're trying to stick to. So for example, one new option is to return a callable, and hopefully that's intuitive enough by itself. Probably everybody's familiar with Java util concurrent callable. It's just a simple interface with one method that can be called, and it returns an object. So effectively what we're doing is the controller is returning, instead of returning a value as normally, now we're going to return a callable that can be invoked asynchronously, and that's what's going to produce the value. Then we have something called deferred result, and that's a new type, which is an alternative to a callable. So with a callable, as you'll see, Spring MVC will actually invoke it in a separate thread. So if you have something that you want to take off of the main servlet thread, then it can be executed with a callable. With a deferred result, it's kind of the opposite of that. Instead of having Spring MVC execute that, what you really want is you want to say, just suspend the request, and I'm going to produce the result later on. You don't need to be concerned how that's going to be produced. So this is convenient for situations like JMS, AMQP, where you have some external thread, or even add scheduled, these kinds of scenarios where the thread is completely outside what Spring MVC knows about, and all you want to say is, I will produce the result at a later time. We also have a return type called Async task, which is just a wrapper around callable, allowing you to provide more information about timeouts and things like that. So taking a closer look at callable, essentially we're producing a value from the controller method, but we're going to do that asynchronously. And the important thing is that this callable is going to be kicked off immediately in using a thread pool, and that's something that you can configure, but it's basically something that Spring MVC will manage for you. So if you have an operation you're calling out to a third-party API, or if you have a long-running database job, and you have a choice. Either return to the client immediately and tell them come back later for the results, or you can make them wait, if that works, without actually burdening your servlet container thread pool. And once the callable completes, it's going to produce a result, and then we're going to do a dispatch, and then that result is going to be processed. With deferred result, we have sort of the opposite of that. We don't want Spring MVC to start any threads. We still want to produce a value asynchronously, but in a thread which is managed outside of Spring MVC. So again, JMS or AMQP listener, or it could be another HTTP request that comes in and basically makes that result available, if you think about a chat application, for example. And then async task is just a simple wrapper around the callable, which allows you to override a few things, like what's the default timeout value, how long before this request times out, and you can actually customize the async task executor for that specific callable. So the idea here is that if you think about what we're doing with callable, is we're swapping out the servlet container thread for a application-specific thread. And the value there is that you can have a more specialized thread pool which is geared towards that particular execution, instead of the servlet container thread pool is really for processing requests. It's not for general purpose doing long-running tasks. For that you can configure multiple different thread pools and then use them appropriately. So you may have one thread pool for making calls to Facebook, or another one for database operations, and then you can configure them specifically for those scenarios. Question?
This is a question I had asked Juergen in the previous session. If you want to have a multi-part response, so I can't be done with a single callable or a single deferred result, right? Let's say file transfer is a good example. Simple use case. I want to say I've finished 25%, 30% or X% of my job, and when the final job is done, I want to say I'm done with it.
Mm-hmm.
Is there a pattern that you have that I could use?
So the question is if you want to return your data little by little, not as one object. Yeah, so basically what you can do in that case is the controller method allows you to take an output stream. That's the servlet output stream, so you can get direct access to the servlet output stream, and then you can write to that little by little. But this is a little different from, when you want to actually write some JSON, then when you're done, you write your JSON. It's more for situations when you want to stream something back to the client, a little bit at a time.
So the controller is calling, say, application service. The server is sending notification, you just want to stream it out. At what point do you close the response?
At what point do you close the response? It's up to you to decide when you want to close it. Yeah, that depends on the application. But it's well, I mean, it should be sufficient for doing the kinds of scenarios that I'm describing here. For example, JMS or AMQP. I'll show some examples. We've built some examples. So I would suggest starting from there to get familiar with what's available. I think the scenario you're talking about might be a little different. I'm not sure yet. I haven't heard enough. But we can also talk about it later on, and I'll be interested to hear more about it. But just keep in mind that when you talk about HTTP request response semantics, there are certain things that are possible and then certain things that are more difficult. So if you start thinking about HTTP streaming, for example, that's a little different. It's not supported necessarily in all browsers. It has some of the same challenges that WebSocket as technology has, which we'll talk about tomorrow, maintaining an open connection through proxies, and what happens with proxies sometimes trying to cache the data that they're sent, interfere basically with that. So we'll get back to that. Okay, so we'll take a look at a little bit of code. So I'm going to show some code from the Spring MVC showcase, which has been updated with Spring 3.2 features. And specifically here I'm going to show you a package with async related functionality. So for example, we have a controller which demonstrates the ability to return a callable. You'll see essentially this looks like a regular Spring MVC controller, except instead of returning a string, for example, it's returning a callable that produces a string. And you'll see here that we're just producing the result. And then everything else, like @response body, that works the same way, except the data is going to be produced from the callable. So that's one example. And you can return pretty much anything that you can return from a method. So for example, in this case, I'm just returning a view name. So this is not a response body method. It's going to go through view resolution. So in this case, I'm just returning a string, which is going to be interpreted as a view name. And I'm actually taking the model, which comes in, and I'm just going to, add things to it. Right? Then we'll talk about exceptions as well, but let's take a look at the application. Make that a little bigger. Okay. So if I go to the Async tab, Essentially, these are all the different tests that I can run, and they each take about a couple of seconds to complete just to simulate something going on in the back end. So for example, if I click on this, a couple of seconds later, you'll see the result next to it. Same thing here. This is actually JSP rendering. And then in the back end, one thing I think that would be useful to see is the actual output that happens. So we'll just repeat one of these. So you'll see I have the actual threads and the time, so we can make out what's going on. And then initially, this looks like a regular Spring MVC request. We have the dispatch of servlet processing. We're going to look up and find a controller that can process it. We actually find the controller, which is our controller. And then you see here that the controller decided to start concurrent processing, and that was done by returning a callable. Simply the fact that you return a callable indicates that you're starting concurrent processing. So once we realize that, essentially the framework servlet exits all the way out and leaves the response open. Then the next thing you see is actually the callable being executed in a application thread, which is in a thread pool that's managed by Spring MVC. And all that does is just sleep for a couple of seconds. You can see here from 49 to 51. And then the result of that is a view name, and also we updated the model. And then we're going to dispatch back into the container, and now you see the same output as earlier. Now we're getting back into the container. This is again similar to a forward. It's a dispatch back into the container to continue processing. And then everything here is going to look the same until at some point right before executing the controller, Spring MVC realizes, oh, there is a concurrent result which was produced. So rather than invoking the controller, this time it's going to continue processing with that value that was produced asynchronously. So it's a bit of a, kind of a disconnected process if you think about it, but we have a synchronous model, the servlet model, and then trying to build on top of that an asynchronous processing is basically something that requires some degree of compromise. And the Servlet 3 API is actually influenced by the JD Continuations API, which has been around for a while. Maybe some of you are familiar with that. Essentially, this notion of suspending the request and then dispatching back once the results are ready, that essentially comes from there. Question?
What's the overhead here for the, I don't know if you call it context switching, but pause, resume, and especially if we were to orchestrate multiple tasks and then we want to kind of collect the results, or just, you're not going to do that, you're dispatching more than one task and then waiting, you've got a bunch of these being handled by the container. How does that scale?
Yeah, so the question is, how does this scale in terms of switching from the servlet thread and then back to the application thread and then back to the servlet thread? Well, presumably you wouldn't do this for something that was quick to execute. This is presumably for something which takes longer to execute. And in that case, what you're actually doing is you're swapping out a servlet container thread for an application-specific thread. And that application thread pool is something that you can configure appropriately for, with the max number of threads, with how many of them should be cached at any time, and so on and so on. All the goodness that thread pools provide. So essentially, you're swapping out for an application-specific thread pool, which is configured for your needs. So yes, there is a overhead, but the idea is that releasing the burden on the servlet container thread pool is important enough to want to do something like this.
Do you guys have support for sort of a manager-worker pattern where you have a bunch of related tasks and then you want to?
Is there support for manager-worker pattern? I would say that this is something which is now a little less related to the web. That's something which can be managed kind of separately. In this case, we're simply trying to manage the keeping the open response open. How you actually produce the value, that's something that you can decide. What you do within that callable, for example, is something that you can decide what's the best way to do that. Did I see another hand? Yes. Correct. Yeah. So a good point, actually. The question is, the browser is still waiting. Yes, the browser is still waiting all this time. We have the request response semantics. Remember, we're not getting away from that here. Yes. So you could use this from through an AJAX request, indeed. So within your browser, you actually wouldn't necessarily see it in the UI. Of course, you wouldn't want to do it too many times because within browsers, you want to limit how many open requests you have at the same time. Yes. Well, I mean, so the question is, aren't we just pushing off the problem to a little bit further down the line? Well, I would say the thread pools of servlet containers are configured in a specific way to handle incoming requests. They're very high-level, general. They don't make a lot of assumptions about what you're going to do. They sort of assume you're going to do it in the fastest possible way. So you're trying to optimize, how many requests can you handle concurrently, do enough to process the request, to pass off to the application. But then from that point on, you hope that the application isn't going to block for a very long time. And if you know that you're going to do that, then you can sort of trade off the thread pool container, let it be managed and configured and thought about separately, making that assumption true. But then within the application, you have the choice to manage. And, often also developers versus admins, you have different concerns, and sometimes you don't even have the choice to ask for how it should be done if it doesn't make sense from their point of view, when they're configuring the whole environment. One more question and we'll continue because...
Since you're
Yeah.
fronting with the threadful executor
Mm-hmm.
to handle off, you're fronting it with a queue, right? So the queue, you don't have to launch as many application threads as you get servlet threads for the requests. You can queue them and then run it in a limited number of threads. So
Yeah, so we're getting to that. So the question is, can we run this in a more limited number of threads? Yes, when we look at deferred result, you'll see that actually it's much more efficient. So, these are kind of two different scenarios, and it really depends on what you're trying to do and what you're trying to achieve. So I'm going to switch back to the presentation. Okay, so what happens if we have an exception that occurs in the callable? There is an example of that. Essentially, again, the idea here is that the way you think about the controller, what you know about the controller, you should be able to kind of guess what should happen. So in this case, if you try to guess, if you have an @exception handler method in your controller, it's going to be handled. If you have other exception resolution mechanisms configured, everything you know about Spring MVC, that should work as well. But it just the context is a little different. You've got a asynchronous thread processing, an exception gets raised, but then we do a dispatch, and that dispatch will handle the exception. So it's a bit more drawn out under the covers, but actually from a programming model perspective, it should be quite simple. One second here. So the handler exception resolver mechanism gets involved like with any exceptions and request mapping methods. Now with deferred result, and actually I should show that as well. So some of the links we have here are with deferred result, and I'll just show you the controller. So with the deferred result, we have a slightly different scenario. You can, for example, see a method which is equivalent to that one we saw with Callable, except in this case, it's also a response body method. So eventually it's going to produce a value that will be written to the body. But it's returning a deferred result, and also very importantly, it's adding it to some sort of a queue. So we're going to hold on to that because we want to write to it at some point. So the effect of that is the response remains open. We don't complete it, but we exit. And then down at the bottom, you will see a method here. And of course, this is just a sample app, not a real app. It's meant to simulate something imagine a scenario. But effectively, we just loop. Here we have a scheduled method which will be invoked every 2 seconds. This is one of the features of the Spring Framework. And we're going to loop through the queue, and then we're going to produce some kind of a result. And yes, it's very simple, it's very trivial, but it's just meant to demonstrate that you can accumulate your deferred results and then write to them from some separate thread, like responding to JMS, or and I'll point you to some real examples. This is just a showcase. And it's important to actually also mention that when it comes to deferred result versus callable, you can think of them as being very similar in terms of what to expect. They're different mechanics, like one will produce a value by being invoked passively and returning a value, while the other one, you actively have to produce a value. But what happens from there with that value, it's pretty much the same things. So they're kind of very similar in that way. So how do we actually produce an exception with deferred result? Well, we have a method to set the result, and we have a method to set an error result. So if you don't want to complete with regular outcome, you can actually produce an object which can be an exception, in which case it will get processed like an exception was raised after the dispatch. So again, on a programming model, should be very simple, but actually there's quite a bit going on to make that happen. And also we have servlet filters, which need to have async supported flag enabled in WebXML. Now filters can be executed from more than one thread. This is something important. So a lot of the filters that you think about normally, they get invoked a single time, right? Then there's forwarding and all kinds of things, but they just get invoked once on the way in, once on the way out. Now we have a scenario where they're going to get invoked more than once, because you have the initial servlet thread and then the dispatch servlet thread. But the Spring MVC filters have all been updated to work in these scenarios, so you can just use them as is without having to think about it. And then if you are using any outside filters, they're going to have to be basically adapted to support not Spring MVC necessarily, but Servlet 3 async support they have to provide on some level. Question? Tomcat valves. I'm not sure, but I would imagine that they support, they provide support for async changes for the async API, because it is part of Tomcat after all, and Tomcat is the one providing. If you find any challenges, I would say file those tickets. They get fixed pretty quickly. I went through that process for a few other things. Handler interception, this is another thing to consider. So we have a new sub-interface called Async Handler Interceptor, and what it allows you to do is it allows you to intercept the request on the way out and to detect that after we started concurrent handling. So instead of process and after post-process and after completion, you're going to get a method called after concurrent handling started. So if you look at that interface, the Java doc, it sort of explains the scenario. Then we have support for configuring all of this, and that's something that you can do through the MVC Java config. How many are using the MVC Java config? Just a show of hands. Oh, we got a few hands here in the front. MVC namespace. Okay, a few hands as well. So with the MVC namespace, you have an async support sub-element of annotation driven, and you have a similar method configure async support in the MVC Java config. So you can just go from there, and that will tell you what the options are. But what can be configured is, first of all, the async timeout value. So if you think about processing asynchronously, Tomcat by default sets it to 10 seconds if you don't change it. But if you want to change it, you can actually specify a different timeout value. You can also choose to configure the default thread pool. That's the async task executor. You can use an async task executor for other scenarios in Spring. This is a Spring abstraction. But you can plug it in, and that becomes the default thread pool which will be used. And if you don't, then there is one which is configured by default. But I would strongly advise you to configure one of your own, because the one used by default is the simple async task executor, which creates a new thread every time. So it's really not the most effective one, but we just don't know what the application, how to configure something. The application really should do that. And then in the WebXML, you do need to make sure you have the async supported flag on all filters and servlets. And this is important. So as long as the request can go through that filter, doesn't matter if the filter actually will do something on the asynchronous processing, but that async supported flag needs to be there in order to allow requests to go through. And then there's dispatcher types, which can be configured on filters. This is something which is a little tricky across different containers. You just have to see how it works for your container. They have different defaults because the spec doesn't mandate it. But in order for the filter to actually get invoked during an async request, you have to include this dispatcher type. That has to be configured as well. And that can be quite a bit repetitive. So we have a web application initializer. For those of you, and I know it's not many on Servlet 3 containers, but we have a class hierarchy which is there to allow you to configure a dispatcher servlet quite easily. So it automatically registers a dispatcher servlet, takes care of all that boilerplate that we talked about, including the async supported flag, the dispatcher type, all of that configures automatically by default. And this is, it can be as short as that. Just extend the base class, specify your root configuration classes, specify your servlet configuration classes for the dispatcher servlet, and then also other things like the servlet mappings, any filters. And the nice thing about this is that both the dispatcher servlet and the filters will be prepared for asynchronous support because we provide that support. So we assume that that's something that we can just enable, and then it's up to you whether you return a callable or deferred result. That's how you actually enable it. So there's no chance of accidentally somehow using async support. That's why we enable it by default. And then if your controllers actually return that, then it gets used. A few references. These are actually live links, so when you go to the slides, you can click on each of those links. First of all, I showed here the async tab of the Spring MVC showcase. So there's a whole bunch of really basic examples to start from to get familiar with. The Spring MVC showcase also shows how to test this from a unit test perspective. Then we have the chat sample, which unfortunately I don't have enough time to go through that in detail, but that's basically demonstrating how to do a chat application using all of this. And there are two branches there. There's in the master branch you have the simpler version of it, which basically just stores the messages in memory. And whenever you chat, those messages are stored. And then there's a Redis version of the sample. So we have a Redis-backed version of it where the messages get stored in Redis, which kind of opens interesting possibilities because now you could be running on any number of servers and the messages get shared across quite easily, the chat messages, and yeah, that makes it quite nice. So we're going to be receiving updates no matter which server we're on. We receive updates from Redis and we just set the deferred result and the chat messages appear. So if you take a look at that, I would encourage you to look at the Redis version as well. I think it's the better version. Then we have the Spring AMQP trading stock sample, which previously used polling. So I created a branch there, which is using the Spring MVC changes, and that's doing long polling to much better effects. And there's a blog series as well that you can read. Yes?
Do you have anything for comment integration?
When you say comment, can you clarify?
So async notification push mechanism to the client.
Yeah, I mean, effectively long polling is a way of pushing to the client, right? So it is a comment technique. It's one of the basic comment techniques which now can be implemented in with Servlet 3 support and using Spring MVC 3.2.
Nothing directly built in with the bio client.
Nothing for bio, no. Yeah. Okay, so changing topics, we're going to be talking about reporting errors in REST scenarios. So if you compare traditional web applications versus building REST APIs, in traditional web applications, it's relatively easy to present an error page. You just pretty much map any possible error through a handler exception resolver to some kind of an error page and then just put it up and say something went wrong. But in a REST API, we need to be a little bit more nuanced than that. So we're going to be presenting status codes, we're going to be using headers, response headers, and it's very common to actually want to write some information to the body of the response as well. So what do we need for that? Well, first of all, we need to be able to write application-specific, to have an application-specific and application-wide strategy to write details to the response body. So if you imagine implementing Facebook or Twitter and you want to write something to the body of the response, you want every error that comes out of your application to have such information. And that should include the Spring MVC standard internal exception. So as you probably know, when Spring MVC comes across an error, like for example, certain content type is not supported, it's going to produce a 406 or a 415. We have something that does that automatically, but it's not going to write anything to the body because we don't know that you're Facebook and we can't assume what should be written to the body of the response. So there should be some way to actually pull in the processing for the Spring MVC exceptions. So ideally you would like a global exception handler method as well because you want to write to the body of the response. And then also some alternative to the default handler exception resolver, which is what handles the standard Spring MVC exceptions. So for global exception handler methods, how many of you have wished you ever had one, global exception handler method? Okay, a few hands, some nodding. So what you can do now is you can put a controller advice annotation on a class. And that's a component annotation, which means that it declares this class as a Spring Bean as well. And when you add exception handler methods to that, it's basically like creating a controller, but without the actual request mapping methods, just the exception handling methods. And there's nothing else to configure. Just make sure this is in the component scan and this class gets discovered or it gets declared somehow as a Spring Bean. And those exception handler methods now are going to be applicable across all of your annotated controllers. So I think that's a pretty awesome addition. So now again you have a choice. You can make your exception handler methods local to your controller, or you can make them global by putting them in a controller advice class. There are some other useful use cases. We started with exception handling, but if you think about it, init binder methods are actually very useful as well, global init binder methods. So if you want to configure a property editor which is going to be applicable globally, or you want to do some other customization to the data binders that get used, well, this gives you a mechanism to do global data binder initialization. Also, you can have model attribute methods. So really anything which belongs in a controller, except for request mapping methods, you can put it. You can think about putting that in a controller advice class, and that gives you global pre-handling. So if you're always adding some attribute to the model of every incoming request, then this gives you the opportunity to do that across controllers, not just a single controller. Then we also have a replacement for the default handler exception resolver. So this is a new class which is intended to be a base class to be extended by applications, and it helps you with processing the Spring MVC exceptions. It does the same thing as the default handler exception resolver. So if you get, for example, media type not supported exception, it's going to give you a specific status code, and all these exceptions are mapped to specific status codes, but actually the return values from the methods are a response entity, and it makes it really easy to basically override this class and then decide what error information to put in the body of the response. So if you're doing a REST API, now you can pull in the Spring MVC exceptions and have an application-wide strategy to write to the body, just making that easier, essentially. Something else which is worth mentioning, not necessarily a Spring MVC feature, but something that came around in Servlet 3, which I think is pretty useful and maybe could have been there for a long time. So you know that if you have an unhandled exception in your container, what you're going to get back commonly is an HTML formatted error page. And that's not very nice if you're doing a REST API because, who wants HTML in the body? Also, if you set the status to any of these 400 or 500 error codes, such as when you say response.send error. This is really the only mechanism in the Servlet API. You just have to do send error, or you have to set the status code. And if it's to one of the 400 or 500 errors, what you're going to get back is actually the HTML formatted page. So to deal with that, in the Servlet 3 environments, what you can do is you can use the error page element in WebXML, which probably most of you are familiar with. It allows you to map specific exceptions to status codes or to error pages. But actually in Servlet 3, what's new is you actually don't have to map that to any particular exception. You don't have to say for which status code or for which exception. All you have to do is just specify a location, which can be a JSP page, or it can be any URL, so you can actually send it off to a controller as well, and that can serve as your override of the default Servlet container page, and that can come handy for closing the loop on some errors that are bubbling up to the container if you can't catch them anywhere else. There's a couple of those that can happen. So the other thing you're going to want to do is, of course, you're going to want to write the information to the body of the response, so you're going to need to know what's the exception that was raised, what's the error message, and what's the status code. And that you can get because the Servlet container will create these request attributes before sending off to the error page. So if you write an error JSP page, you can just access those request attributes, or if you send off to a controller, of course the controller can access request attributes as well. And the exception handling reference chapter in the reference documentation has been updated, so you can take a look through to get familiar. And then also the Spring MVC showcase has a package. In the package for exceptions, it has a demo of using the controller advice global exceptions. Content negotiation strategies. So this one should be relatively straightforward to understand. Before Spring 3.2, essentially if you use response body, or if you used request mapping produces for mapping purposes, essentially that worked off of the accept header. That was content negotiation, because the assumption is in RESTful scenarios, accept header is what drives content negotiation. However, these methods can also be used to work with browsers, and sometimes browsers pretty much don't send predictable or similar consistent headers. So for this reason, the content negotiating view resolver actually always offered lots and lots of options for content negotiation. In fact, probably many of you know, but the resolver out of the box looks at the extension of the URL, looks like for .json, .pdf to decide what kind of content to write, not at the accept header. Because the assumption is if you're using this resolver, you're probably working with browsers, and browsers just don't send the kinds of headers that can be helpful. So what the essence of this change is taking the configuration options of the content negotiating view resolver, making them first-class possibilities to configure content negotiation in Spring MVC, and then exposing that through the MVC namespace, the MVC Java config. So we have a new abstraction called content negotiation strategy, which has different implementations, one for using the accept header, one for using the URL extension, one for using a request parameter. So this is also something which is done sometimes. Or you can have a fixed content type, which can be handy in some cases. Like, for example, if you're trying to always render your errors in JSON format, right, regardless of how is being requested, then this might be something that would be useful to you. So we have all these different strategies. You can configure them each, and you can order them. So you can have, for example, you can have URL extension first, accept header second. You can decide what's the best strategy. And in order to put it all together, we have a content negotiation manager, and that can be instantiated with any number of content negotiation strategies, and it can be plugged into all the usual places, including the handler mapping, the handler adapter, and the exception resolver. So you can really now plug that in. And of course into the view resolver, into the content negotiating view resolver. What are the default settings? Well, as usual, in the MVC Java config and the MVC namespace, we make bolder changes, sort of not necessarily preserving always backwards compatibility, but sort of trying to make the most, because it's really the more opinionated way to configure Spring MVC. If you're using one of these options, then you probably appreciate that help, essentially. But it does mean that when you upgrade, it may not give you the same behavior as before. So what are the defaults there? If you're not using the Java config in the XML namespace, then we very conservatively preserve backwards compatibility. So we start with accept header, and that's the only option, really. So if you're not using the Java config or the MVC namespace, you'll have to configure it and make sure that it's to your liking. And that matches to the existing defaults, essentially. But if you're using the Java config, then the defaults are going to match to the content negotiating view resolver, which is you're starting with the path extension first, then you're looking at the accept header. And the other nice thing about this is that if you have a JSON library on the class path, or if you have JAX-P2 on the class path, it automatically registers the .json and .xml extensions. So that should just work basically out of the box. So that should be pretty sweet. And there is a section on configuring content negotiation, but it's pretty straightforward for the Java config and the XML namespace. And the Spring MVC showcase actually has examples with using .json and .xml now. So you can take a look at that as well. We have matrix variables as well to talk about. First of all, what are they? I mean, I think a lot of people are familiar with the term, but I had to become familiar myself with all the details, and it's one of those parts of HTTP which just haven't been used that much, and there's actually diverging kind of notion of how to use them, and they were, as a term, matrix variables were originally mentioned by Tim Berners-Lee in a blog post, which you can find quite easily if you search for matrix variables. And that's a link to the post, actually. But the term itself is not used in any of the RFC specs. So if you try to look for matrix variables in the HTTP spec, you're not going to find it there. But it is a commonly used term, and it's very distinct. You know, we could have gone some other names like, you know, path parameter, but these are such general terms, and they're used in other places that, you know, we felt it would only add confusion to do that. So if you look at the RFC spec, what it actually says is very, very general. It really doesn't talk about matrix variables at all. It just says that each path segment can actually have a sequence of parameters associated with it. And that's something separated by semicolons. So that's the main characteristic of it. You have semicolon that separates name value pairs which are on a specific path segment. And the order is not significant, so all of that is going to matter for request mapping purposes. And then if you look at the later version of the RFC spec, 3986, it actually expands on that and makes it even more general, even more loose of a definition. What basically says, you know, these are reserved characters, and they can be used in different ways, and, you know, this is the most often way it's used, but it can be used in other ways. And that sort of makes it very difficult for a framework to actually try to pinpoint it and, you know, implement it. Because if you look at what's happened, there's actually two different types of usages that you'll find in the real world. So one of them is what you would expect, which is the path segment name value pairs. And this is an actual example from JFrog, which is the company that makes the Artifactory, which is where we're hosting now our artifacts. So you can have, for example, and the URL can be much longer, but just didn't have enough space here. But you can imagine a URL that points to an artifact, like a, I don't know, like a Spring jar, Spring core jar. And then for each path segment, you might be attaching some kind of specific properties or some specific attributes. So in this case, we have a QA release, and we have a build number, a revision, and you can imagine doing that on every path segment. So that's kind of one style of usage. And then the other style of usage is using delimited path, using that as a delimiter, just sort of general delimiter. And that's something you'll find in the Stack Exchange API. So for example, here you'll see answers based on specific, identified with specific IDs. And in order to provide multiple IDs, they're separated by semicolons. So that's a kind of a very different beast altogether. Instead of name value pairs, these are just individual items. In this case, we just have a list of things. That's what we're trying to do with the semicolon. And for request mapping purposes, these are actually two very different things. And you know, both of them have the semicolon in the URL, and we have to decide at some point which one of those two things you're trying to do in your application. So what to do in Spring MVC? First of all, if you do expect semicolon content to arrive, if you're building an API that's taking advantage of this, then essentially you'll want to represent that with a URI variable. Because the order of these parameters is not predictable, it can change, it's not mandated to be specific. They may be optional as well, so it's really going to be impossible to make a literal path for request mapping purposes and then expect that's always going to match. So first rule is you have to put some kind of a URI variable in the URL in the place where you expect them to appear. And most often you're going to do that by representing the whole path segment. I think I would recommend doing that this way. And then you use an annotation as usual. So here's an example. Above you have the expected URL. So we can have a couple of extra parameters added, matrix variables, to the last path segment, but it doesn't have to be the last path segment. It can be any of the path segments, really. And you're going to represent that part of the URL with a URI variable, that's the pet ID, because really the way you think about it, that path segment represents the ID. And then you're going to extract what you need. So you have a path variable which gives you the first part of the path, right? That's the actual value of the path variable. And then you have a matrix variable. In this case, it's named Q, so we don't have to explicitly name it, but if the variable name is different, you can also specify it, so there's other attributes on the matrix variable there that you can specify. There's also a way to obtain all the matrix variables, and you might be familiar with that from other annotations we have. Essentially, just provide a map, and the only difference here is that you see here we have type conversion. So if you ask for them individually, you'll also get the type conversion. That's just, you know, bread and butter Spring MVC. But if you get it in a map, it's just a map of strings because we don't know what kinds of objects they represent. And then in some cases, and this may be rare, but I'm sure somebody will come across it, you may have a variable which is named exactly the same but in different path segments. And in that case, you'll actually want to qualify which one are you referring to. So this is where you'll see that the matrix variable annotation allows to say which path variable are you talking about. In this case, the owner ID, in this case, the pet ID, and you can disambiguate in this way, but only if you have to, not otherwise. And we do have a section on matrix variables in the reference docs. I should mention that if you try this today, it's not going to work, and that's because I found a bug as I was trying to add it to the Spring MVC showcase yesterday. Oops. So that's going to be fixed shortly, hopefully. But you have the information on how it works, and RC1 should be available about a week after. And the next topic I want to talk about, and I think this is going to be exciting for everybody who is writing Spring MVC applications, because really the ability to test controllers is something that we've tried to work on providing much better options here. How many of you are familiar with the mock HTTP servlet request and response? Okay, most everyone is. And of course, these are just, you know, I would call them stub implementations of a request and response. That's the simplest way to understand them. And they're part of the Spring Test module when you need to use them, and they're very commonly used in controller unit tests. So typical controller unit tests, you just instantiate the controller, maybe inject it with some stubs or mocks for your business services, so you're not going to the actual database. And then you start writing your tests, and you're calling the controllers, passing the model, whatever arguments you need to pass. But the trouble with that is that all the annotations which are in the controller are actually not going to be tested, right? It's not actually going through the same runtime environment that you have when the application is in production. So you're testing what's inside the controller method, but these days the controller methods rely on a lot of things being passed in, so there's lots of opportunities for things to go wrong if you didn't configure the right type converter, if you, if you didn't add something through a model attribute method correctly. So there's tons of opportunities for things to go wrong. So the idea here is that we provide better, take these controller unit tests and provide better options there. And we're going to involve the dispatcher servlet, because that is how we're actually going to invoke them with all the annotations. And we're going to use a Fluent API, which makes it very easy and very sweet to write these tests. I just had the pleasure of adding them to the Spring MVC showcase, which didn't have any test cases. So there was quite a few actually tests to write. So I had to experience myself firsthand how quickly it is to write them. And I have to say that I'm pleased with the results. You can actually run these tests based on your real Spring MVC configuration. So that's an added bonus, that you can test your actual Spring MVC configuration, and all of that without a servlet container. Because under the covers, what we're using is the mock HTTP servlet request and response and the dispatcher servlet. And the combination of these two, we can start processing requests without actually a running servlet container. So here is an example. This is only a partial example. It's not doesn't show you everything from start to end. Doesn't show how you initialize this thing called mock MVC. But assume you have this thing called mock MVC, which allows you to perform requests. So you can say perform a GET request to /foo and have this accept header, and then when that's performed, expect the response status to be 200 or OK. Expect the content to be a specific content type, and then if the response has some JSON in the body, you can actually use things like JSON path or XPath to verify specific things. So there's lots of options on that side to try to verify what's in the response. And since do we have a little time? Yes, we do have a little bit of time. So I'm going to show a few tests just to give you a better idea. So like I mentioned, the Spring MVC showcase has lots of tests, and I'll just pick one randomly here. So for example, in this case, so let me just show you the base class as well. This is a new annotation, and that's something we're going to be talking about on Thursday. But this is showing the support in the test context framework for loading web application contexts, including the ability to point to your actual web files. So in this case here, by default, this is pointing to source main web app, but I don't need to put that there because that's the default. But I can actually point to where my web app files are, and if I have tiles definitions and other things, it's all going to load as expected. And then I can do that and then just inject back here, inject the web application context. That's really my web configuration. And now I can simply create a mock MVC object. That's my base for testing server-side controllers. Give it my web application context, and then start testing. So I'm going to say perform post, and then expect this kind of content to be returned. I can, these are basically the various methods from the Spring MVC showcase. And if you want to know what's going on, for example, you can always say and you can see I'm using here code completion support. So a lot of these methods, in order to achieve a Fluent API, we're using a lot of static methods here. So for example, here the post is actually a static method. But if you make these, and I'll be talking about this on Thursday, but if you make these classes that provide the static methods favorites, you can configure them as favorites in Eclipse. When I do, you saw here that I can actually use code completion for that. So I can say P, and then it knows that print is a compatible method there. So if I run this now, oops. So here is my full information about the request that I sent. I can see which handler executed it, which method. Were there any exceptions that were resolved? In this case, no exceptions were raised and resolved. Any other information, then I can see the response. So it's very quick to actually see what happened as a result of that. You can quickly fire requests against controllers, then see the results. And there's various ways to assert, so you can do, you can expect specific JSON content, or you can use JSON path, XML, and so on. Lots of options there. So there's a lot more to talk about in this area, but that's what we're going to do on Thursday morning. So if you're interested in this, come for that talk, or I will make a link available to the slides, and you can also take a look at the slides. Tons of resources. Within the Spring framework itself, there are sample tests, both client-side. So this actually has client-side support as well. If you have REST template-based client code, you can actually do some testing with that. So we have examples of client and server side code, and then we have the presentation on Thursday as well, and of course the Spring MVC showcase. A couple of other improvements to mention is we have a generic HTTP message converter, which is an extension of the HTTP message converter that you all know about. And what it does is basically for libraries that support generic types, we have implementation. So for example, with Jackson, or with the JAX-B2 collection. So the typical use case on the client side is you're using the REST template, and you're going to specify what type should be brought back. And that should be, let's say, a list of integers. Well, there's no way to say list of integers in Java, right? You can't say list. You can only say list.class. You can't say list and then of ints. So this is a way to do that. On the server side, when you have @request_body declared on a method, similarly, you can't say, even if you say list of ints, it actually is not possible. That information is not available at runtime without specifying it somehow. So as part of this support, what you do on the client side is you create an instance of parameterized type reference, and in that you specify what's the generic type. The little trick to see here is that this is actually an anonymous class that you're creating. These curly braces at the end is a key part to this. It's a bit of a sort of workaround, you might say, but it's the only way to do it in Java, and it's actually, this is not something that we invented. This is something that, that is known as pretty much the only way to retain such information at runtime. And then you pass that information into the REST template, so you can say, I'm expecting a list of ints. Now you can actually get a response entity with the list of ints coming back to you. So that's the benefit there. On the server side, there's nothing extra to do. You can just say list of integer, and now we support it as long as the underlying technology supports it. So if you have, for example, JSON. Or in the case of JAX-B, if the incoming message has a root element and then all the sub-elements are of the same type, then we're going to convert that into a collection. So we'll handle that. And that's only for reading. For writing, this is really not necessary if you think about it. We support the HTTP patch method, which there's actually not much to the support other than you can use it wherever you need to specify an HTTP method. So there's nothing extra that we do beyond that. But if you want to work with the HTTP patch method, you can. Jackson JSON 2 support, you can upgrade. And we have, for XML-based configuration, we have a convenient factory bean for configuring a Jackson object mapper with tons of options on it. In terms of what's coming next, after 3.2, we're looking to WebSocket support. Servlet 3.1, the spec doesn't seem like there's too much in it right now, but there are certainly some items that we'll look to support. Externalized request mappings. So currently you can configure your Spring MVC controllers with annotations, but there are cases when frameworks do that as well, and sometimes they want to be able to customize that. So I, as a developer, will write my controllers, but then it's actually a product which somebody else will need to customize when they use. This happens in portal environments or frameworks like the Spring Data REST framework, and Spring Social as well has Spring MVC annotations. So it would be nice to be able to externalize somehow and customize these request mappings, and we're going to be looking for some solutions there. Declarative caching is another topic which has gathered quite a few tickets in Jira, something like being able to specify the caching headers through annotations. That's something that we're looking at. And with that, I'm going to open for questions. Yes?
I have a question about the asynchronous processing. So since the asynchronous part, the logic is executed by different threads. So I know the framework itself will put some variables into the thread local, for example, like theme or
Okay.
locale. So are they available?
Yeah, so the question is when there are multiple threads, usually when you process a request, you have some thread locals, for example, for say if you have transactions or Hibernate, if you're using things like that. Yes, so those things are handled. All the open session in view filters and all of those have been adapted. The framework Servlet itself puts some thread locals for the request context. Those are going to be handled as well. In the callable, when we execute the callable, we're going to do that. But when you're using a deferred result, you're completely outside of Spring MVC, and there, I think it's actually natural to understand that those thread locals won't be there because you're responding to a JMS event or AMQP event, and that's outside basically. Any other questions? Yeah.
Yeah. How will Spring MVC 3.2 work with Spring Security?
Okay. How will Spring MVC 3.2 work with Spring Security? I presume with regards to async support. So the Spring Security filter, which updates the thread locals to have your security context, that will need to be customized to do that. In other words, Spring Security will have to make that possible. It's not going to work out of the box automatically. But that said, it's actually relatively straightforward to do that even before Spring Security provides it. So it shouldn't be a huge deal, but hopefully around a similar time we'll have something in a release that will make that possible. We've adjusted all of our filters within the core Spring framework, and now Spring Security will need to have a release that does the same as well. Yes?
A quick question. In the beginning you said that there's not a lot of movement going on with Webflow. What does that mean? What's the plan there?
Yeah, so the question is about Webflow, not really this necessarily, but so Spring Webflow, there is actually movement there. We've moved to GitHub, for example. We've made it possible to submit requests, pull requests there, kind of changing the process more easily. We have a issue repository that we've created on GitHub as well, which makes it easier to submit tickets. We've cleaned up, bringing up to take advantage of Java 5 and compile with Java 6. We're doing a lot of other items like that, kind of taking it forward. There's not a lot of new features coming in at the moment. Partly, we want to know what else you would like to have in Spring Webflow. We think Webflow is actually pretty complete in what it does, and the main opportunities that I see at the moment is providing closer integration between some of the new Spring MVC features, like we're going to be adding, for example, support for flash scope. When you exit the flow, sometimes you redirect to a controller to show a final confirmation page. So it would be nice if you can actually use the Spring MVC flash scope once you finish to carry it over to the controller. So things like that will continue to appear, but by all means, just not really. There's tons going on in Spring MVC and lots of things that we need to support. It's just in Webflow we don't see as much there. I mean, there was a plan at some point for version 3 with Java-based flows. And I think the results of those experiments weren't very conclusive. I'm personally not convinced that the Java language syntax will make it any better than to write actually a flow definition in Java. So we're looking at other ways to simplify rather than making it easier to invoke flow actions and things like that. Kind of the annotated model that we have in Spring MVC, bring that to Webflow.
So you don't have any plans for Webflow specific support, for instance, for the async and DC methods that you just talked about?
That's something we can look into. Like I said, as Spring MVC moves along, we have opportunities to take some of those features back into Spring Webflow. URL for the slides, yeah. So let me get back to the beginning. Okay, any others? Yes?
How does the Spring Async work with Tomcat clusters?
How does it work with Tomcat clusters, the async support? Well, I mean, it really is orthogonal. I don't see any cross there, because when you start a request, again, it's a request response semantic. The browser sees just a long running request. The browser, from a browser's perspective, they're just waiting for the response, essentially. So. Yeah, and it's the same server mostly that's handling the request to complete it. Now, indeed, with a deferred result, you would still want the same server to finish it, to finalize it. So, and that shouldn't be a problem. So I don't think there's any crossover there. Okay, well, that's pretty much it for the presentation. Thanks for attending, and enjoy the rest of the conference.